My name is WOO YOON, and it's a good chance to introduce K-STAR as a case study for the panel session in international data management policies and practice in this conference. So this work has been done with the K-STAR team and also the expert in the Princeton Plasma Physics Laboratory. And the content, I have a few slides to introduce the development of nuclear fusion energy worldwide, which will include the ITER, K-STAR, and also the roadmap for the demo development. And the next to the topic is the international large-scale data transfer for the real-time analysis, which will include the strategy for the ITER operation with the distributed resources worldwide, and also the demonstration of international test data transfer at K-STAR. So starting with the ITER is the International Thermonuclear Experimental Reactor. Its main goal is a final engineering demonstration of the commercialization of fusion energy. It actually started in 1985 and lasts 35 years up to now. It has many examples in the time, but finally it is a quite good stage right now. Its completion rate at the end of the last year, it's most of 73%. So it's right on track right now. And it is located in the southern France called Cadarache near the Aix-en-Provence. And this is the international effort to realize magnetic fusion and, for example, to demonstrate the scientific and technological feasibility of fusion power for peaceful purpose. And we have 7 parties and also the international organization of the ITER come together to support a success of the ITER construction. And when you look at the main project objective is so-called fusion gain. Q is the ratio of the fusion power to the input power. So we have a factor of 10 more of fusion power required than the input power for this is kind of minimum requirement for the fusion reactor. So this is the main goal, and ITER will start operation in 2025 and to achieve Q equal 10 in 2035 as everything goes well. And ITER is a genuine international project, means that the member states provide in-kind, not the cash-based contribution. So for example, this is the ITER machine with the important components. And for the K-STAR, for the Korean side, for example, so we are dealing with the thermal shell and the vacuum vessel and the toroidal field coil and the blanket module for the success of the ITER. And move on to the K-STAR. So this is a smaller size fusion machine, but has many things in common with the ITER. That's why it's a good test bed for preparing the ITER operation. And the main goal is long-time operation of high performance plasma. And we have a diagnostic device in the middle of the mid-plane of the discharge, which will provide all the information of the plasma, fusion plasma in the tokamak device. So if I comment shortly on the recent development K-STAR, it has succeeded to sustain the long pulse mode up to 90 seconds. And also one of the important parameter for the fusion realization is very high ion temperature, which requires more than 100 million degree. And actually K-STAR demonstrate that we can sustain this kind of state more than 20 seconds. And for the Korean fusion energy development roadmap, so we are starting with the last decade and continuing effort for the K-STAR. And this decade, we are focusing on the ITER construction. And the next decade, we are working on the demo for the electricity generation. And everything goes well and smoothly, we can get the first kind of the commercialization of the new energy, fusion energy in 2050. So stay tuned for the development. And let's move on to the main topic for the test data transfer internationally. ITER operation is a challenge, but also an opportunity. The global nature of the ITER project is, it actually generates petabytes per day. And it's not only a unique challenge, but also an opportunity for the fusion community to rethink or optimize and enhance our scientific discovery process. This is kind of illustration we have in mind for the ITER operation. So starting with the ITER experiment, they will generate a lot of diagnostic data and will be transferred to the remote simulation center or data center whatsoever. And combined with the machine learning technique, we can do the learn higher accuracy modeling or simulation near to the real time. Then we can do the feedback right away to the ITER site for the machine operator. When you look at the typical scale of the ITER, I mean, it spans from the real-time control to very short time, milliseconds, and for the live and intershot analysis is second to minute. And for the scientific discovery, of course, it takes a longer time. So the main purpose of this kind of distributed data operation is focusing on the real time and the intershot analysis, which means that we focus on the minutes operation data transferring speed. So in this regard, the K-STAR is a good test bed for sharing large scale data. So the reason is the K-STAR is operating up to 100 seconds of plasma operation, which will generate lots of data. And many of the data from the multidimensional diagnostic with high time resolution. And also we have a strong international collaboration to check this kind of fast data transfer. And this is one of the example of the what K-STAR diagnostic provide. And this is the imaging diagnostic of electron cyclotron emission, so-called ECEI. And as you can see here, you can look at the data, what's going on in the plasma in the imaging like movie in the inner and outer, and we can go to the nearly 3D visualization of what's going on inside the plasma. So this kind of information is important for the scientists to look at what the scientific mode activity and turbulence transport. So using this kind of diagnostic, we are doing the measurement and near real time visualization at the remote institution for the analysis. So we are based on the very fast data network. For example, here from Korea to the US is through the ClearNet, and also in the US you are using ESNet. This is a 100 gigabps fast data network, so we can utilize this infrastructure. However, the fast network is not the end of story, and we have to be very careful on the framework of the transporting protocol. So so-called Science DMG provide the faster and secured route for the large-scale scientific data. As you can see here, this kind of when you look at the schematic, this kind of DMG switch or router has an important role to secure the fast data transfer with minimizing security burden. So this is the previous K-STAR PPPL data, the transporting experiment, which has a lot of small packet loss. However, after adopting the Science DMG, we have all of the bandwidth recovered without any issue. So this is one of the improvements we have. And also the scientific analysis based on this distributed resources has many interesting features. For example, this is a typical data network, and we have a multi data transferring system to maximize the bandwidth. And also when you look at this bottom image, so starting to getting the data from the K-STAR, and when you're sending the data, we are using the ADOS IO format, which is adaptable input-output system, which include the good compression technique and also the hierarchical structure and through the network transfer. So usually scientists are looking at only the part of the interest data or the whole data. So this kind of hierarchical data transfer system is really important with the minimum bandwidth, minimum traffic. So when you move to the PPPL, then we have a visualization of the what we have transferred from the K-star, and also there is another data from the another simulation center in Oak Ridge to do the fundamental simulation. You can measure, we can compare these two images in situ, and then you can get the clear idea of what's going on the experimental side in near real time. So when you look at the performance of the large scale data transfer at K-star, so I have to emphasize that the science TMG is must to get the higher bandwidth, higher transfer rate in domestic and also the international. So the record is like 15 gigabps, I mean data transfer achieved between K-star and the NUSC server, it all through the 100 gigabit server system. So this is the summary. So I mentioned that the development of fusion energy, including K-star and ITER and K-demo in a timeline, and also the main topic is international large-scale data transfer for the real-time analysis, which include the ITER preparation, and the K-star is a good test bed, and also we demonstrate the fast data transfer between Korea and US using the Science DMG and the ADS protocol. And I have to mention that we are continuing the development of the framework for the international collaboration on ITER and beyond, built on the principle of performance, flexibility, and adaptability to support the fusion analyst scientists to enhance the scientific analysis. Thank you for your attention.